Okay, just a quick announcement. Today, right after class, we have 3 hours office hour academic search to cover both homework 4, homework 5, and also the discussion with your final project. So I just want to tell you that right now I like to focus a lot on the final project discussion. I would not too worry about homework 6 right now. The only reason I haven't released it is because the reference implementation of homework 6 will contain the solution to homework 5. So I cannot release immediately. I just realized otherwise I have to remove part of the code, which I'm not sure that will be a good idea or bad idea. So just let you know that homework 6 is, you will get a lot of help as well as a team. That's just a quick announcement. So we're going to talk about, continue to talk about function template. Last time we talked about the concept of pointer. So now I'm going to go into the chapter, both chapter 8 and chapter 9, and also then lead to chapter 16. So those 3 chapters are the main focus of the next couple lectures. So first I need to talk about the template. So there are multiple kinds of template. One is called function template, which we're going to focus today. And you can also do class template. It's a similar idea. And then on the way, you will learn that there are some templates already being developed, reusable for you. In fact, the idea of template is actually reusability. For example, I have a piece of code looks like this. Let me move this down here. Can I actually, sorry, I want to move this things down here. It's blocking the view. Okay, now I should be better. Okay, wait a minute, it's still come back. I thought I moved down there. Anyway, forget it. So did I? Yeah, I didn't cover anything important over there. So essentially, you think about you have a piece of code, assuming it's a very simple code. Try to find the minimal value. I mean, the smaller value contain 2 objects or 2 basic types and try to put it in. So on the left is try to compare 2 integer. On the right, try to compare 2 double. Essentially, what you're doing is, well, can I use just one function, and then so I can use it whenever the programmer decides what is the type. So a lot of this template is essentially trying to generalize a piece of functional logic to cover different kinds of data type. So the way you define it, as a simple example, I hope you can see it, is there is a few keywords. The first is a keyword of using template. You say template. And then you use this bracket of small sign and greater than sign. Inside there, you put one or more of the data type you would like to have. So essentially, I'm using this as a one data type you need to manipulate, but later you will see you can put multiple data types there as well. So what I did here is I said type name T. Okay, I said type name T, and then essentially the type name is going to be replaced by when you call it, you're going to replace that type name with either double or with an integer when you use it. But you actually declare the type name to be the capital T. And that capital T is important for you to complete the rest of the template. And then you define your function. So now your function, when you define, after you have the first line has 2 keywords. One is a template, one is a type name. And then you're going to declare the function, basically say, whenever you see capital T, is going to be replaced by whatever the type name you put in there. Okay, so it's going to be, it's going to return if it's double, the type name is a double, then it's going to return the double. and the input argument, both A and B is going to be double. So essentially, you are, if that type name is double, when you use the template, then essentially you're getting the code on the right. All right, everything is like that. And not only you can compare two basic type, you can actually also use a type name as a class. So now you can actually compare two GPS location, and then whatever the operator overloading on this smaller between two GPS DD is going to take over. Okay, so be careful when you write the template. Sometimes it might trigger your operator overloading on those variables. Okay, so this is another example. I can actually really write a template looks like this. It's more complicated, has more than one type name, because my return type and my argument type might be different. So in this case, you can see that I have actually 3 different types, assuming I implement a food, which has the return type is TRET. I declare they're using type name keyword. And the second type is TARC1. The second one is TARC2. Essentially, what I try to do is return type, I want to be a pointer to JSON value, which is just like in your homework assignment number 5. Return type is JSON value pointer. Okay, JSON value star. And TARC1 is person star. And type 2 is actually JP tie star. And so if I actually use those, then when I actually call the function. So this is the way after you declare this particular function template, then you can actually just call it this way. The way you call it is, of course, you need to now provide those 3 types. In this case, it's TRET, T argument 1, T argument 2. And then you basically write the function name is food. You still declare the function name itself. But then you actually provide the type of this. Oh, sorry, the food need to be the template, the name of the template. Sorry about that. And then you provide the 3 type, which is correspond to the 3 type. And then you input your argument. So essentially what you have in this line is a usage of that template with whatever type. So you can see that we can potentially make a fairly complicated function that using this kind of at the compiler type. Okay, at the compiler type, by the way, to bind the type to the function. Okay. Okay, any question? All right, we're going to see some. Now we're going to see some example, and then this example will get more and more complicated. We're going to bring in function pointer and lambda expression using function template together using this example. So we're going to use this example a lot today. So now I'm actually defining another template in the green. So what this template is basically saying that I want to declare a generic function template to decide whether an input argument is within the range. So essentially, you can think about the logic is that I want to input a value to this function, and I want to compare a range. And at this stage, the range is basically determined by the user of the function template, depending on what they want to use. So essentially, so now you're seeing that the function template is not only help you to change the type of the value, but also it actually help you to change the range of certain parameters within the function. So in this case, I actually declare the function type is double, but the range is actually an integer, because I mean this is the I don't know if it's the blessing or curse about the programming language. Sometimes you can have this kind of mixed type comparison. You can compare a double and the integer, and the compiler will recognize this is a mix. So they will basically convert the value to do the right thing, and then you will be able to compare them accurately. Okay, so essentially I have 3 argument in the template. One is the type name, and then I have a two range, which is upper and lower. And you can see in the template code, I'm essentially compare the argument value with the upper and also the argument value against the lower, so I can decide whether the return is a bool. Okay, is a Boolean value. So this is the template we wrote for is in range. And essentially this piece of code, the compiler is going to generate when you actually use this template. This is, by the way, this is the template itself, syntactically. This is how to use the template. When you use the template, you just say, the template, you say, is in range, double, and then, wait a minute. Oh, yeah, 500 and 0, and then value looks like this. And then that's how to use the template is in range. And then when you actually write this line of code using this template, then basically the compiler is going to translate your code into this part on the blue. Okay, so that's give you a more a little bit more complicated template example with both data types, and you can actually set up the value. Okay, any question? All right, good. Let's go to the next one. So I'm going to get more complicated into this template. So the next thing I'm going to teach you is about pointer to function. I know some of you are already familiar with this topic, but I just want to go through that a little bit about how do you actually specify a pointer to a function. So essentially, I said the function is a piece of code in the memory map that I showed you last time. And essentially, functional pointer, just like a pointer to a data type or to an object, that's the first byte of the object. So function pointer is essentially the first byte or entry point of that piece of code. So that is called function pointer. That essentially gives us a chance to manipulate how you can rearrange or control flow within your program. I mean, to be honest with you, you might see that why do I need function pointer? Why do I need the address to do this? But in reality, is compiler is going to compile everything to function pointer anyway. By the way, your code, when you write the code, looks like this. The compiler is going to get everything into a function pointer format because that's actually the low-level machine really can understand. So just let you know that. Okay, so I'm going to first tell you how do you actually declare what is a function pointer. So this is the yellow box is just the syntax about how you can declare something is a function pointer. So there are usually about 3 elements you need to have in order to declare something is a pointer to a function. So the first thing you have to declare is the middle called func, PTR. So this is a real declaration. If you want to declare this func underscore PTR is a function pointer, you actually write this line of code. This line of code basically say func underscore PTR is a pointer to function. This is actually doesn't bind you to anything that's actually operational. This is basically just purely declare what is this variable's data type. So, I mean, this is actually equivalent to integer star func PTR. So if you say integer star func PTR, what do you declare? You declare this is a pointer to an integer. And what is a func PTR? Sorry, integer x func PTR. Then func PTR is what? Is a pointer. Pointer means it's an address. It's a 32-bit or 64-bit unsigned integer, essentially. So it's just an address. So this is the same way. When you declare func PTR like this, it's basically saying that I'm just assign a pointer. I mean, yes, it is a type is a pointer to function, but I haven't assigned any function yet. So before I assign anything, it's just a pointer. From the memory map consideration, in most of the system, when you declare that, that pointer is pointing to null. So remember I told you if it's pointing to null and you try to run the function, of course you get a segmentation fault or bus error because you try to access the memory region that's actually prohibited for any program to get into. So that is just a data type. So let's see more about this data type. So as for function pointer as a type, you actually say star this one, and then you actually, of course, the function has to have a return type. So you actually need to provide a return type. And then you provide your argument type. I mean, assuming this is only one argument. So essentially, this declaration is saying that it's a pointer, FUNC_PTR is a pointer. But what kind of pointer it is pointing to a function because you have this bracket after that. If you see something like a bracket, you know it's a pointer to a function. So now we know another thing is that you need to put that parenthesis after that function pointer name to tell people tell the compiler that it's actually a pointer to a function. But then it's actually asking, well, I know, okay, it's a pointer. I know it's a pointer to a function, but what kind of function it is? What kind of function you're pointing to? Because that's important. We need to check every data type. So that's why sometimes you hear me saying that a term called function signature. So for example, when you develop homework 3, I always check whether your function signature is consistent between the HW3 server.h and HW3 server.cpp. Sometimes we make this kind of check. For example, if the number of arguments mismatch, then the function signature doesn't match. So over here, when you declare a function pointer, you also need to provide the function signature specified according to that pointer. So that's why, what is the function signature? Function signature is what's the return data type? It's a bool in this case, or whatever t return. And the number, both the number of argument and the data type of each of the argument has to be specified. So in this case, let me just interpret this is that essentially this is a function pointer that pointing to a function that's actually return type is a bool. And it only has one argument. And then that particular argument's data type is double. So that's what this line is saying. Okay, so next time if you see somebody write this line, it just basically say that. It just basically declare that this is the function, a pointer to a function, and what is that function signature that is pointing to, but it hasn't pointing to anything yet. When you declare this, it's a null pointer. It's not, but it's going to pointing to some function matching that function signature at a later point. Okay? Any question? All right, so essentially that is a pointer, assuming I have this pointer, this function called is in range with this double assets, then it can actually store it over there. Let me actually see this example over here. So you can see that I have that function I already declared called is in range. And then this line, you can see that I actually declare. This is the line I actually declare function pointer double. So this is declare a pointer with that function signature, but still nothing is binded until this line. See, this is the line sometimes you might not have a lot of experience to this line. This line essentially assigns the address of the function to a function pointer. So I already have this function declare called is in range. So I basically, when I say is a range, is actually mentioned, this is the way C works or C++ works. When I say is in range, using that as a function, it's actually mean the address or entry point to that function, the first byte of the function, whatever. And then you can assign to that function pointer. So after this, you know that, okay, not only I declare a function pointer, but I actually bind the real function into that pointer. I actually provide the value, and then I can actually just call it. Okay, when I call the function, this is also something maybe new to you, is essentially do this. You see that I put a parenthesis here, and then I can start function pointer. So function pointer is pointer to a function. So I put a star means I actually derive from the pointer to the content. So that's actually become the function. If you think about that, this is very consistent with how you use a regular pointer and function pointer. You do a star. If it's an integer, star xp, and now you say star xp, that will give you that integer it's pointing to. So similar here, if you use star, function pointer is actually pointing to the function that you're pointing to. So this part basically give you the function you're ready to call. The rest is just provide the parameter. Okay, so just remember this example that actually tell you how to generically do three things about function pointer. To declare that it is a function pointer. How do you declare that as a variable? That's a type, is a function pointer. The second one, you need to assign the value. You need to initialize the value. And the third one, you need to call that function. Okay, so that's the function pointer. Any question? Okay. I try to see some of the code you can actually provide to see this. Oh, I know what I want to tell you. If you think about virtual function, I really hope I can actually look at the code that was generated by C++ compiler to convert all the code they did virtual function using function pointer. So if you think about what is a virtual function is determined when an object is created, which version of operator equal is going to be called. Is this going to call the fly, the real objects operator equal, or this is, sorry, person, because operator equal is associated with person. Is this going to associate with person.cpp, or is going to associate with shadow person.cpp? So person, colon, operator equal is a function. It's a member function, but it also means that it has a pointer. And also, shadow person, colon, operator equal is also a member function. It's also a pointer to the function. The concept is the same over there. So therefore, the way it works in virtual function in general. So this is a little bit advanced, but programmer should start to understand why the language was designed that way. So when you create an object, what it does is that if the compiler realizes that, okay, this function you declare as a virtual function, then essentially they will arrange the call differently. Usually it's called what? It's called by just directly hook you to the member function you're supposed to call. But if I know this is a virtual function, I'm going to actually create something called v-table. It's a virtual table, just like homework assignment number 4, you actually have a v-table. So that v-table has a particular location as a pointer that corresponds to operator equal. So essentially, anywhere the code try to call operator equal is actually going to the pointer, retrieve that pointer from the virtual table and use that the way you use it here, essentially. So essentially, you go to the virtual table, retrieve that pointer, and essentially, virtually, you put a star there, and then try to call that function. Okay, that's what compiler is going to do. Compiler is going to make sure they detect this is a virtual function. So I'm going to shuffle that, create that pointer in the virtual table of this object. Well, now at runtime, because I actually don't know. Remember, what's a virtual function? I mean, if we have a final exam or midterm, if we have, I will ask you what is the definition of virtual function? If you remember, is that it will be determined at the time the object was created. Okay, that is the definition of virtual function. So essentially, at the time, what do I mean by when the function was created? So at runtime, what I'm going to do is that at runtime, when I create this object, when I create it, I know whether this is a shadow person or this is a person. So at that time, I'm going to assign the shadow person column operator equal that function pointer value into that virtual table of this object. So you see that the compiler will do part of the job. It's just recognize the virtual function, it create the virtual table, they know where it is for each of the member function I'm going to call for virtual function. That's called V table. But then at runtime, when you create an object, when you create that time, you're going to really assign the value into that V table. And then when later you call, when you actually try to do, really do operator equal, it's actually going to check whether this is a shadow object or it's a real object. It's a shadow object, I don't know. I don't have to know why, because that binding is already in my V table. It will naturally retrieve that pointer and then call the pointer over here. And that's how things get done. Okay, I know this is kind of advanced a little bit, but just as a C++ programmer, it's good to know how the virtual functions really implement. Okay, any question? All right, so let's actually take even further into this topic. So I said, okay, you can actually declare a variable looks like this with a template and with this value range over here. And I can actually do this. I can actually make it is a function pointer, but that function pointer is pointing to a template. So essentially, I can actually use the function pointer together with a template idea. So you can see that I'm actually, let me just compare what's different. Here, you actually just say is range to do this. Okay, so you still declare this function looks like this. This is just declaration for the type, and this is how you bind. But you can actually bind it to the template itself as well. Because template, when you realize a template, it's a function. Again, when you say is range double 500 0, it became an instantiation of that template. And instantiation means that it's a function. Then I can actually assign that to a function pointer, and then I can just call it. I mean, the code will work just as it is. Okay? You can see that now you know what's a function pointer, what's a function template, and you can actually use both of them together. It's quite nice to use them together, very easy. You can get more powerful usage of this. Okay, here is the summarization of the function template and pointer. There are two things. I just want to share with you this two green box, which is how you declare a template, and the yellow box is how you declare a function pointer. And then they have a model how to use this. Okay, any question at this moment? All right, so now I'm going to make it more complicated. It's called Lambda expression. So when we talk about function a lot, this is in chapter 9, now we'll move to chapter 10. But sometimes I just want to declare a function, but I don't want to give a name. I mean, sometimes you might want to give a name, but sometimes you don't want to give a name. I mean, sometimes you don't want to give a name. The reason is that I just don't want to be worried about the name because this is going to be a very generic way of using this code within whatever template. And you will actually see that. It's actually Lambda expression is very useful when you want to pass in a function as a pointer. I mean, by the way, you can pass function pointer as an argument as well. But you can actually pass, probably a better way to pass as arguments using Lambda expression, which I'm going to show you. They're all related, by the way. Function template, function pointer, Lambda expression, they're all related. So I'm going to continue to use this example. I'm actually going to say, this is another way I'm actually writing that piece of code I just gave you about the range. So over here, I mean, when you look at the code, what's your first impression? This line started with auto. What do you get from that piece of code? By the way, that piece of code is called Lambda expression. First, it's actually overloading this idea called bracket. So the idea of bracket here is what we call Lambda expression introducer. So basically you say, hey, this is a Lambda expression, which is sometimes as a C++ programmer, when I first look at this, I say, why do you have an array without the name of the array? No, it's not an array. Just sorry, it's confusing. It's just like sometimes you saw function template show smaller sign, greater than sign. It's not smaller than greater sign. It's a function template. So let me actually tell you the syntax. This piece of code, by the way, is exactly the same as all the code I have shown you so far. Functionally, they're exactly the same. So this is the way you declare an array. Let me pass that to you. Is that you have the red is what we call Lambda expression introducer. I actually show you this. This is probably easier for you to see. Okay, the first one is called Lambda introducer. You might have some option to put in there, by the way. I will tell you that later. And then you can actually declare what we call parameter. This is kind of also reverse, that they first actually talk about parameter, then talk about return type. This is something I don't like. The design of Lambda expression is somewhat inconsistent, say with template. With the template, you first specify return type, and then specify the argument type. Here is you first specify the argument type, input argument type to the Lambda. So when I say Lambda, it's a function. It's just a function without name. I call it Lambda. So this is the input argument, and this is the return type. So essentially saying that this Lambda is basically taking input as a one integer, but it could be as many as you want, and then it's going to return a Boolean. Okay, that's what it's saying. It's a double argument value, whatever, and then return the Boolean. And then inside the function, this is called function body, and you can do whatever you want. I mean, this is only one line, but typically Lambda expression, you don't want to write, usually it's not a huge line of code, because otherwise it gets really ugly. But it's actually the body of the code is inside here, and you're using this argument value in here. So this code is essentially equivalent to this piece of code here. I'm just using the Lambda to tell you a very simple way of doing Lambda. Okay, so there are 4 elements you should remember: the introducer, argument, return type, and the body. Those 4 things, that's actually you can put declare a Lambda expression. Now let's go back to the original example. So basically, I declare IIR as a Lambda expression. So this is a very similar to function pointer, but it's actually a compiler concept. The compiler basically take that Lambda expression, replace it, and put it there, and basically try to call that function using IIR, but not the start. The difference between IIR using Lambda expression and using function pointer is that when you call it function pointer, you need to put parentheses star that func ptr, but Lambda expression you just call IIR. That's it. All right, they're all the same. Any question? Okay, so now I'm actually going to do something a little bit more complicated to mix all the 3 concepts together. Function template, function pointer, and Lambda expression all together. So let's actually take a look at this piece of code. This piece of code is not new. I showed you this already earlier when I used both template and function pointer together. Just want to tell you that this is how we do that. Oh, by the way, you can write this piece of code, add it here, and try to print the value of function pointer, try to print the address. You actually, this is good because I sometimes feel most of the programmer, especially Python programmer, Java programmer, they never need to worry about this. But as a C or C++ programmer, sometimes it's good for you to just take a look, where is your function? And you actually know where your system placing your variable or pointer or function to different locations. When you print a pointer, you use this is called format string, and use %p. It's going to print the pointer format for you nicely, print something looks like this. And for you to see that it has a decimal about your address. Okay, so I'm actually going to change that. I'm going to use a Lambda expression mixed with function pointer, and you can actually do it this way. So this is essentially saying that, okay, I'm actually going to have a function pointer declare, but I can assign this function pointer to a Lambda expression. I can actually specify that, and automatically that function pointer is going there, and then I can actually still call it using whatever star function pointer. So you can actually use these two concepts in a mixed way you like, okay? But the interesting part is really this part. I can actually mix Lambda expression with template, function template. This sometimes could get complicated, but it really gives the programmer a lot of power in using a more advanced template. And by the way, so far, you haven't used any of this kind of template. You haven't developed such template. Most of the template that we have been using didn't use Lambda expression. So what you will see is that the idea of using Lambda expression with template is that the template was designed such that you have to use it precisely the way it's doing. But over here, I'm actually trying to do in a way that I can manipulate the behavior of the template by shuffling a Lambda expression into that template. So meaning that what's a Lambda expression is a function. So I'm actually change the behavior of the function at compiler time, by the way. So the way it works is that you can see that I'm actually having template, the same thing with template and type name T, type name F. But the thing is that is a range. I now have argument value. Then the second argument I provide, the type, is actually a Lambda. It's a function. So after I shuffle that, my Lambda is essentially just doing my Lambda argument value. So just call that function. So I'm using the second one as a function for me to call within the body of the function template. So that's how you can use the two together. I'm not saying you should use this all the time, but if you actually develop a lot of code, you realize you want to have a template that with a capability that you can on the fly change its behavior. Then you can actually use the Lambda expression together with this. Okay, let me actually tell you that this you have to think about has to be careful because a lot of case this is powerful, but it's hard to understand because the template, number one, the template is essentially not so easy to develop when you allow somebody to actually shuffle a piece of code in there, unless you really know what's going on. And the second thing is that this might introduce some vulnerability of the code when the code gets bigger because it's harder for you to understand what's going on. But anyway, if you want to do this, then if you actually declare a template looks like this. By the way, this is the real code for what we just talked about. You can run it, and you actually, when you call it, you just call isArrange 35.0, and then you actually write this piece of code as a Lambda expression. That is how you can use that template. But remember, I told you the warning. When you look at this piece of code, I mean, unless you're really, really familiar with the syntax and semantics of Lambda expression, I would say this piece of code is really unreadable. Will you agree with me that this piece of code is really hard for a normal person to read? Especially if you develop a code, you left the project team, and somebody else is going to pick up this thing. And when they read this code, they would just say, okay, I'm going to rewrite this piece of code. because I just cannot handle that. I mean, a lot of the time in software team, they look at this code review, they look at this, no, if I can find a better way to do it, I probably would make it more readable. Readability of the code is very important, just to let you know. So to make it better, I mean, this is the way I will write. If I'm really going to write this piece of code, I will write the code looks like this. At least it has more structure. So by the way, not criticizing anyone, but when I actually saw your code during the office hour, when you bring in the code, I actually spend a lot of time trying to tap your code in such that it provides a structure for me to read, because I realized at least 2 students, I remember the arrow that you have is nothing to do with your misunderstanding about the code. It's because the tabbing is incorrect. If you're tabbing incorrectly, then you cannot see, oh, here I miss a curly bracket, or here this line is really associated with outside of the if then else loop. That's usually the situation. So it's always a good habit when you write a code as a programmer to provide this kind of what we call structure. And just compare this piece of code and this piece of code. You can see that this piece of code is so much easier for help us at least understand what this code is trying to do. I know that the first one is going to be input parameter. The second one is a Lambda expression, because I have that introducer. I actually see that, okay, that is the input argument, that was the return, and here's the body. I write the code looks like this. So it helped me to kind of parsing it to develop a better readable a code with both the concept of template and the Lambda expression together. Okay. All right, I'm going to just close it. And oh, the other thing I should actually talk about is that, okay, now I'm talking about the introducer. The introducer essentially has 3 different formats. The first format is just default, okay, independent default. The second introducer is that essentially you can provide read-only access to the variable within the scope. So which means that if you write a Lambda expression, that this Lambda expression will be able to read the variable that's declared within the scope that include that Lambda expression. So what do I mean by that? If you have a function over here, I mean, this, I don't have any extra variable, but I can potentially add a variable right after here. I can actually have whatever integer or object over there. And that variable, I will allow the body of this function to actually have a read access to that. That's what's, if you put an equal sign, if you put an M sign, that's actually rewrite. You can actually modify the value. Okay, having said that, the reason I actually didn't even want to show you an example, I feel the third option is highly undesirable, because you put a piece of Lambda expression. By the way, when I say that, it's because Lambda expression is going to move to inside a template or inside other thing. So you basically have a piece of code to rewrite access to the code when I call a Lambda. That's kind of really hard for me to imagine that whether there was any kind of bug that's actually not trivial or security problem, not to mention that. So Lambda expression is powerful, but it has some how do I say that, complication that if you make a read right. I mean, read only might be okay for some occasion. It's appropriate. It's always remember whether it's appropriate for you to use it that way. Okay, but I just want to tell you, there's an option. You can just have a default introducer, which is independent, means that I'm only processing whatever within this Lambda expression. But if you want your code to be interact with the environment it was being called, then you can consider this 2 option with introducing equal, that means it's a read-only. With M sign, that means it has a rewrite, has all the authority to access everything within the scope of the function. Okay, so this is what I talk about today. I'm running out of time. we talk about three things: function template, function pointer, and Lambda expression. And that's corresponding to syntactically, that's the syntax. The first one is the green is a function template, that how you can actually declare that. And then the yellow is the how you declare a pointer to a function. And then the third one is just using this introducer to have this concept called nameless function. We call it a Lambda expression. And you can use it, it's powerful, but just be careful, say it again. And these three things can potentially hook up together. I wish I can do a little bit demo because I have actually pulled out the code. That's actually, you can twist here and there to learn more. So the simple program over here, I remember I actually showed students like a 4 different functions that you can actually put this together. It's quite fun just for learning. I'm not saying you should use it, depend on the situation, but there is a code that for you to play around and really learn this concept. Okay, I'm going to finish here. Any question for today's lecture? All right, so we're going to move on. Next time, we're going to talk about class template and also standard template, like given that you're the no. So for the textbook, I think we covered chapter. Okay, so now you know what we talk about. We covered chapter 8 and chapter 9. Okay, and then next time we're going to cover chapter 16. All right.